12 volts light installed 2 feet above the water level and 1 foot outside the water's edge may not be legal, though a definitive answer requires careful consideration of applicable electrical codes and local regulations. Several factors influence the legality of such an installation. Firstly, the National Electrical Code, or NEC, Article 680 covers electrical installations in and around swimming pools. This article provides specific requirements for lighting fixtures, transformers, and wiring methods to ensure safety and prevent electrical hazards. Secondly, the height and distance of the light from the water's edge are critical. The NEC specifies minimum distances for luminaires installed near pools to prevent accidental contact and reduce the risk of shock. A light fixture located only 2 feet above the water and 1 foot away might not meet these minimum clearance requirements. Thirdly, the type of transformer used is an important consideration. The answer states that the transformer is pull and spar rated and has a grounded metal barrier between the primary and secondary windings. This type of transformer is designed to provide enhanced safety by isolating the low voltage secondary circuit from the higher voltage primary circuit. The grounded metal barrier helps to prevent voltage from crossing over in the event of a fault. Fourthly, the light fixture must be rigidly mounted and sealed to the wall. This is important to prevent water from entering the fixture and causing a short circuit or corrosion. The sealing must be adequate to withstand the wet environment around the pool. Fifthly, the specific voltage of the light, 12 volts, is generally considered a low voltage system, which reduces the risk of electrical shock compared to higher voltage systems. However, even with a low voltage system, proper grounding and bonding are essential. Sixthly, local codes and regulations may impose additional requirements beyond those specified in the NEC. These local rules can vary depending on the jurisdiction and may be more stringent than the national code. For example, some localities might require a greater distance from the water's edge or specific types of enclosures for electrical equipment. Seventhly, the installation should comply with the requirements for ground fault circuit interrupter, or GFCI, protection. The NEC typically requires GFCI protection for electrical circuits serving pool equipment, including lighting. A GFCI is designed to detect small ground faults and quickly disconnect power to prevent electrical shock. Eighthly, the wiring methods used to supply power to the light fixture must be appropriate for the wet environment. The NEC specifies the types of wiring that are permitted near pools, such as listed underground feeder, RF, cable or rigid conduit. The wiring must be properly sized and protected from physical damage. Ninthly, all electrical equipment used in and around pools must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, ORL. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. Tenthly, regular inspections and maintenance are essential to ensure the continued safety of the electrical system. Over time, wiring and equipment can deteriorate due to exposure to moisture and chemicals. Regular inspections can identify potential problems before they become hazards. 11thly, any modifications or repairs to the electrical system should be performed by a qualified electrician who is familiar with the NEC and local codes. An unqualified person could make mistakes that compromise the safety of the installation. 12thly, the NEC requires equipotential bonding of all metal parts within a certain distance of the pool. Equipotential bonding involves connecting all metal components together to create a common electrical potential, which helps to prevent voltage differences that could cause shock. 13thly, the location of the transformer should be carefully considered. The transformer should be installed in a dry, well-ventilated location that is protected from the weather. It should also be readily accessible for inspection and maintenance. 14thly, the NEC specifies requirements for the depth of burial of underground wiring. Wiring that is buried too shallow could be damaged by digging or other activities. 15thly, the type of pool, whether it is an in-ground pool, above-ground pool, or storable pool, can affect the applicable requirements. The NEC has specific rules for each type of pool. 16thly, the presence of other electrical equipment near the pool, such as pumps, heaters, and control panels, can also affect the installation requirements. The NEC specifies minimum distances between different types of electrical equipment. 17thly, the NEC addresses the use of underwater lighting fixtures. These fixtures must meet specific requirements for construction, installation, and grounding. 18thly, the use of low-voltage lighting systems is becoming increasingly common in pool applications. These systems offer enhanced safety and energy efficiency. 19thly, the NEC provides guidance on the selection and installation of ground rods. Ground rods are used to establish a connection to the earth, which helps to stabilize the electrical system and provide a path for fault current. 20thly, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that wiring should be properly supported, connections should be secure, and equipment should be installed according to the manufacturer's instructions. 21stly, it is important to consult with a qualified electrical inspector to ensure that the installation complies with all applicable codes and regulations. An inspector can review the plans, inspect the work, and provide guidance on any necessary corrections. 22ndly, the NEC is updated every 3 years, so it is important to use the latest edition of the code. The requirements can change from one edition to the next. 23rdly, the NEC provides tables that specify the allowable ampacities of conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. 24thly, the NEC specifies the types of overcurrent protection that are required for electrical circuits. Overcurrent protection devices such as circuit breakers and fuses are designed to protect wiring and equipment from damage due to excessive current. 25thly, the NEC addresses the use of flexible cords and cables. Flexible cords and cables are typically used for portable equipment. 26thly, the NEC specifies the requirements for the grounding and bonding of electrical equipment. Grounding and bonding are essential for safety and help to prevent electrical shock. 27thly, the NEC provides guidance on the selection and installation of surge protection devices. Surge protection devices are designed to protect electrical equipment from damage due to voltage surges, such as those caused by lightning. 28thly, the NEC addresses the use of arc fault circuit interrupters, or SIs. SIs are designed to detect arc faults, which are a common cause of electrical fires. 29thly, the NEC specifies the requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. 30thly, the NEC provides guidance on the selection and installation of wiring devices such as switches, receptacles, and dimmers. 31stly, the NEC specifies the requirements for the installation of electrical equipment in damp or wet locations. Damp or wet locations are areas where there is exposure to moisture or water. 32ndly, the NEC addresses the use of power-limited circuits. Power-limited circuits are circuits that are designed to supply power at a limited voltage and current level, which reduces the risk of electrical shock and fire. 33rdly, the NEC specifies the requirements for the installation of communication systems such as telephone, data, and cable television wiring. 34thly, the NEC provides guidance on the selection and installation of fire alarm systems. Fire alarm systems are designed to detect fires and alert occupants of a building. 35thly, the NEC specifies the requirements for the installation of emergency power systems. Emergency power systems are designed to provide power to critical equipment during a power outage. 36thly, the NEC addresses the use of renewable energy systems such as solar photovoltaic, or PV, and wind power systems. 37thly, the NEC specifies the requirements for the installation of electric vehicle charging systems. 38thly, it's crucial to thoroughly review Article 680.26 of the NEC, which concerns equipotential bonding for swimming pools, and Table 680.26 regarding the minimum size of bonding conductors. The correct interpretation and application of these guidelines are paramount for ensuring safety. 39thly, the specifications for the transformer enclosure are dictated by NEC 314.15, particularly if located in a damp or wet environment. 40thly, the wiring methods used must conform to NEC 300.3, ensuring proper insulation and protection against environmental factors. 41stly, regarding the mounting height and horizontal distance, consult NEC 680.22b, which outlines requirements for luminaires and lighting outlets in relation to the pool's edge. 42ndly, proper conductor sizing, detailed in NEC 310.15, is essential to prevent overheating and ensure electrical safety under load. 43rdly, always consider the specific listing and labeling requirements for pool equipment as stipulated by NEC 680.4 to ensure compliance with safety standards. 44thly, remember that local amendments to the NEC can be more stringent, so always verify local regulations with the relevant authority having jurisdiction or OJ. 45thly, GFCI protection should adhere to NEC 680.22 5, ensuring that lighting fixtures near the pool are properly protected to prevent electrical shock.